Okay, I think we're broadcasting. Cool. I'm just fighting Codex. So I have put my prompt. Okay, so we'll be building private poker, and I came to conclusion that perhaps the verification on chain will be too expensive. For heads-up game, it costs almost $13 to just verify one hand. A little bit too expensive. So I'm exploring alternative. How can I use BLS signatures? I'm going to use Lagrange. So I have this in Chromeball, right? I have this here in BLS. I have this Lagrange here. So Lagrange allows you to combine and recover, right? So what you're doing is you're using BLS secret, private key to sign a message, and you aggregate signatures from many players, and then you have this one signature that is aggregated. So it's not an array, but it's just one value. And then when to get the public key, right? So to verify this signature, which is aggregated from multiple signatures, you need to have a public key. So you have one value now, and how do you verify this one value against all those public keys of the user? So you have to also create some kind of like a aggregated public key, so use this recover here. So this takes shares of the public key, and it creates this master public key, and we submit this as a as a master public key, and then when we have the signatures of something that we wanted to multi-sign, we use this combine, yeah. Okay, so we do that. So what happens in our flow now is we have kind of like a ring structure at the moment. So maybe star would be more, safer, I don't know, I was even thinking about adding option of referees, because I don't know about the fairness of this private poker at the moment, because it's peer-to-peer. So if it's heads up, the players are playing. So what does it mean? Well, you join the table. When you join table, this is on blockchain, right? So you're calling the smart contract method here. This is this lobby thing. There's a hand start. There's a table, I suppose. Where's the table? A cool thing is that I actually wrote the smart contracts as there was like one smart contract, private poker, and then the size of this smart contract became too big because it has to be fitting in 24 kilobytes. And I told Codex, look, Codex, this is too big. We need to split it into diamond. And I already had this. I already knew that I need diamonds. So what I did was I already stored the state. You see, self. This is a trick with diamond, right? So the struct is empty. The struct itself doesn't have any fields. So where is the data? Data is in the storage slots, So you can actually, using a trick, you can access a storage slot or many slots. And in this library here, common, okay, lobby, this main lobby, okay, and it's a composite structure because it also has those lobbies in there and tables, and then now table player. And now we're just adding hand, because after finishing the poker gameplay, we need to submit the hand state so that we know what was the pot, who won, who's the winner. Not sure. Well, there's a pot split. I think I forgot to tell Codex to show the winner, but maybe there is no single winner, depending if hand is split. In a heads-up game, there will be one winner. I don't know. At this moment, it's just like this. A new field can be added. So this is data stored. Oh my god, This is stored on blockchain, on Arbitrum, in this moment Sepolia. Okay, so this data is stored. So this is like normal data, right? So you look at it and it's just data structures, nothing special, and it's Rust. It's not Solidity. It's Rust. It's very familiar, right? So you don't need to learn new language or anything like that. You just can program in Rust, and Rust is beautiful, right? But I'm not saying that Solidity is ugly. There is a piece of Solidity here as well, so I'm a little bit lying. Okay, yeah, so when you join a table, okay, so create table, there is a join table, right? So you join table, so this is on blockchain, so the table itself is created on blockchain as well. So you have a lobby here, and in lobby you would have like create table. It's a lobby. No, sorry, this one only manages lobbies. I think the create table is actually in the table, is it not? Yes, it's here. So because this is like this, there is no table. One player creates a table, another player joins the table. If you want 6 players, then one player creates a table and 5 players joins the table. You know, so they just call the smart contract method to create and join table, and then this table exists on blockchain. That's what happens. Now the hand is not on blockchain. Okay, so we're just adding the final state of every hand, so that you know, when hand is finished, we submit this data. Okay, but it needs to be multi-signed by all players that play the game, and they all have to kind of come to agreement that, yeah, this player won and everyone else lost. You know, so that's a good exercise here. And also we need to check who's the cheater, right? So that's a lot of interesting stuff going on, right? So for this, there's a flow, there's a whole flow, and yeah, let me just see what Codex is doing. It's doing and doing. What it's doing? It's trying to run something, to deploy something. Good news, optimize settler, passes cargo stylus check. Oh, hooray. Let's see what it's doing. Does it do the BLS check? It should be doing BLS check. Let's see if Codex was smart enough. Set table, aggregate public key. Okay, fair enough. Settle hand. Okay. Do we have verification? We have a public key. Okay. Oh, verify signature. Look at this. And oh, here's the verify signature. Digest, public key, and the signature. Look at this. And we have this and multi-miller loop. Bravo. And that's all you need to do, actually. This is the beauty of BLS. You don't need to do any like a loop over players. You can just bang one signature, because this is aggregated BLS signature. That's the power of BLS, you know. So yeah, this is just to decompress from compressed byte array. So compressed is I think without, I don't know what the representation is. It has, I think, less dimensions or something like that. There is a affine version and there is projective version of G1 and G2. I don't remember which one is which. Well, there is G1, there is G2. So compressed is just byte array, you know. So because this is like a more complex data structure. You see, it has this FPs inside, and then affine, I think, is smaller. Affine is having, this was G1, so that's actually G2 affine, but you see it only has 2 and it's a choice instead, so it's kind of less of it. G1 is it's also 2. Okay, then the FPs are same. Wait a second, are they the same? Why is the G2 the same? They shouldn't be the same. It's just navigating me into wrong place. The data structure looks the same. No, FP2. Here we go. This is FP2, so it has 2 FPs inside. You see, I knew it's bigger. it's G2, so it has twice as many of I don't know, coefficients or values, whatever you want to call it. So it's you have two FPs in each of those, and two coordinates, or maybe like this. And then you have this one is just single one. Yeah. And each of those, you see, each of those is 64 bits. So this looks pretty neat, like when you look at it. Like, oh, I just do multi-million loop, that's it. But it's a lot of, the problem is that it's big, it's a lot of bytes. And you saw like 64 bit, like the G2 I think compressed is 96, but when you uncompress it, it becomes G2 project T. No, wait a second, what does it become? Sorry, it becomes G2 affine, but then projective one is bigger, I can tell you that. There's only one projective one here, but it's bigger, it has 3 FPs. So it's gonna be more bytes, each of them is 64 bits, so that's, you know, 64, 64, 128, and then you have 196, no, yeah, 140. I don't want to think about it now. I'm gonna have a drink. Okay, so verification works here, and that's cool. Now what happens here actually? So we verify the signature. What do we do next? So our settle hand, which we'll be calling from Frontend, okay, we pass the lobby table, the split of the pod and so on from the Frontend. So it's actually interesting. You may think, wait a second, so Frontend is calculating all this? How is that going to be fair? Because of those signatures, you know, players agree on the state. So think of it this way: if you sit at the table and play with your friends, you know, you agree with your friends what is the outcome, right? You all sit there and you agree that, okay, I won. So so we have like the quorum is people at the table, right? Yeah. So right now it's just the players. There could be like referees, so like observers as well. So there could be additional non-player characters that also sign or something like that. I don't know. I haven't yet figured this out. Right now I'm trying to make this working. So it's a lot of coding, so I love how Codex is just generating all this. Look at this. I wonder how's my usage remaining. 60%. It goes. You know, it's I'm on free tier, so it's like this trial, you know. Once the trial is gone, I have no money, so I will have no codex. I'll have to code by hand everything. That's fine. I mean, it's taking codex so long. I don't know. Feels like some of that is cool. There's a lot of typing, a lot of like hand typing all this error checks. You know, AI can do that for you. Okay, and also probably there wouldn't be so many bugs. Maybe if I tried it, then maybe that verifies signature would have a bug somewhere. Although, yeah, because this minus, I did it on one occasion. I was by hand implementing this, and I put the minus in the wrong place. Okay. Now, what happens when we verify signature? We basically acknowledge that players have agreed that this is the state. And if that's the case, we take the hand from the table and we put into the hand the data. Now, I'm not entirely sure about this data here, because are we checking digest only? Okay, I need to talk to Codex in a moment, because we shouldn't be updating hand if this verify signature doesn't take this data into account. Digest should be there, but that data should be there as well. I mean, otherwise I could be submitting here whatever I want. So I think this isn't correct, right? You have, like, we're checking those two fields only. And what about that? No one checked that this is the data that should be in that signature. So, you know, that signature doesn't sign this data. That needs to be fixed. We need to make it fixed. Yeah, this is like the bug. I can see immediately that this is a bug. That's my outage. I see those things straight away. Now, I don't even compile it. It's just like, you know. Now, what's going on here? Yeah, I think there was something missing here. I don't remember what was it. Winner. No, I wanted to have a winner here. Although, I'm not entirely sure what I wanted to have here. Digest is here. Digest should be a digest from the whole, like, hand transcript, you know. So that's yeah, it's interesting. Let's just check something. No, you don't want to ask Gemini anything. Yeah, so my private poker, you be in making. Oh, here we go. No. Is it not streaming? I don't know. I don't see myself here. What's going on? Oh well, what can I say? How do I do this? Select stream. Oh, there is thing here. Oh, 4 views. Look at this. There's some people viewing me. Warning. What's that? You won't see it because I removed Op Studio from your view, you know? So you won't see it. There's no chat. If you want to chat with me, how do I do chat? Open chat or something, no? I really don't know how to add chat in here. Select stream refresh page. I think I didn't select chat, or I think, no, it should be here. It's part of this thing. Oh, here it is, chat. Here's the chat. Hello. But I don't see anything in the chat. Oh, there is a chat. I don't know if you can see the chat. If you can type something into the chat. I can't really do anything with this chat because the moment I do this, it disappears. It's kinda not cool. Oh well. Well, I'll check sometimes. I don't know. Okay, oh, finished. Oh, now, what can we do about this? What is Codex saying? But I just wanted to, like, I think the reason for this, I don't know what this is. Accept, reject. I don't want to accept, reject anything. I just want to close this. I don't know. What happens if I reject? Don't touch it, better. Something will break. Review. yeah, we need to review code. So the point is that I want to show you how weird I work with Codex. You know, I have just conversations with Codex, but these conversations are more like explanatory. You know, I want Codex to understand the project. So instead of creating plans, I am having this session and I'm putting into Codex information I want it to remember from me. And I could actually put it into plans, but I don't know, I'm just so fast with coming up with ideas that I just need to dump them on Codex. So yeah, so for example, I just said to Codex, let's remove those smart contracts. And I want a new diamond facet called settler, okay? And diamond facet, so diamond is like, you know, API gateway from microservices. So it's like that. So you have like this API gateway and then you have like services behind it. So here you have like this proxy contract in front and then you have those contracts behind it. You know, and they share storage. So in the diamond here, oh, here you go. That's the diamond. And this is a hard-coded diamond. So normal diamond ERC, whichever number, would be more dynamic. It would have like method add facet. I mean, I think update facet, and there is like operator add remove. Yeah, so this one is more hard-coded. You just have, you see, Rust code that says if this selector is one of those, then you know, then pick the facet. So depending on which function you want to call. So basically the way it goes is you calling from frontend, you're calling a function on diamond, but you're calling on this proxy component, right? On this smart contract that is a diamond proxy. So you're calling a function, and one of those, and they listed here, okay? So for example, I wanna, where is the settler? Oh, I'm gonna call settle hunt, you know, settle hunt. And if this selector is called is settle hunt, so selector is receive 4 bytes. So when you're submitting a smart contract method call, there is some bytes encoded in hex, and first 4 bytes of the call are the selector, and this is those bytes. And if those bytes match any of this, so you can see this is nicely generated by proc macros in Rust, this sol from Solidity interface that we see in here. So this, you see, this is shared library, and here we have but that's Rust, and then we have in Rust you have Solidity, you have this proc macro, and inside of this proc macro you have Solidity. So these are interfaces in Solidity, and you have those methods here. So for each of those methods, then this macro will generate many things. And for example, it will generate those selector, right? So for settle hunt call, so it will generate, for the method is settle hunt, it will generate this iPrivate poker facet settle hunt call selector, which is 4 bytes that then can be matched against this selector. Right, and then we can say, okay, if it's one of those, then we use facet settler, and then this function is called from here. That's a test. Here, from here, facet for selector. So we have selector, and we select facet for selector. So that returns a enum. So we select the actual facet address from main lobby. We have those addresses. So this main lobby is this shared data structure, and here we have facets, a field like this, and this is our struct facet. So this is stored on blockchain, as you know, and it has those addresses of each smart contract. So imagine that API gateway has the configuration of the IP addresses of each other service, you know, of each backend service. So this is the same. This is smart contract, and it's the same thing. It's just address. It's not IP. It's hex. Well, IPv6 is hex too. So isn't that different really? It works differently, kind of, but the idea is the same, kind of. So yeah. So logically, you have this kind of split. and this thing is in a fallback. So this struct here, this is poker diamond, right? Private poker diamond, and at the very end, so these are the methods, okay? And at the very end I have fallback. So in Rust Stylus, what you do is, this is a constructor and it has this special annotation constructor, okay? You have some methods, so you can call one of, like for example, you can call handFacet. This is a method, so you can just get the address of handFacet by just calling directly on this diamond proxy. So if you call this method, it is not gonna go any deeper. It will be just, it's like API gateway, and it, like, you have some endpoint that is directly responding to you. It doesn't go deeper into any service, you know. So this is like that. And then you have this fallback, which is routing into the deeper system. And yeah, so this fallback is doing that. And you see, it takes the call data, and from the, so call data is like this hex, this long hex containing the encoded in bytes, in hex, in bytes of the call, and encoded in hex. But you get here the bytes. So those bytes, well, they're encoded in hex, depending, maybe when you use Rust Stylus, they're not encoded in hex. But anyway, yeah, so you have the whole call, you have the method and the parameters, right? And the first 4 bytes are the selector. So we get the selector, we select the facet for selector, and then we do this magical thing. And in Rust Stylus, you do it like this. So for self VM, so self is this smart contract, which is private poker diamond, okay? So this diamond proxy. VM is, well, a way of like getting into virtual machine on which this contract is running. So you are the contract. VM is the virtual machine on which the current instance is actually running right now. So the Arbitrum node that is processing this. Well, the node itself runs the VM and you are on this VM. And then you tell this VM, okay, I want to call a different contract. And this is the contract address I want to call, and this is the call data, right? So this, it's like your services where your API gateway will be just doing REST call to some deeper service. The difference here is that, well, it is a call to a different contract, but on the blockchain is done in a way like the Arbitrum node runs this VM, okay, and this VM runs the whole copy of a blockchain. So this delegate call doesn't actually make this node call to a different node. It all executes on the same node. It just goes to execution, just goes to a different contract, you know. So it's just like a function call, you know. It's just like a function call. So it goes through some layers of blockchain mechanics, but on the same node, and you know. Yeah, so that's what we have here. Right, so we have this diamond. Let's see if it works. Does it work? We need to deploy it, no? So, yeah, so I did this explanation to Codex. There is some final verification. So that was before we touched blockchain. So I wanted to just do this print to the console on the browser. So this is the data that I will be sending in this settler, okay, into this thing. I'm going to be sending some of this. So, and that is important, because if that happens only in a browser, then the chips are not transferred from one player to another. So we need to do the settlement so that, okay, you played your hand peer-to-peer, but now we need to take the cash and move it from one account to another account. So You play peer-to-peer, the game is over, now you submit your signature saying, okay, we agree that this is the winner. Submit on blockchain, and blockchain doesn't care what was the game, it only cares that you agreed that X is a winner and everyone else is not. So that's what it works like. Yeah, I'm not sure entirely if it's, yeah, need to test it. Yeah, so I told Codex to do those changes. Let's see what Codex said. Oh, 8 players. Any comments in the chat? No. Do you see chat? Let someone type something in the chat so I know if it works. No? Just hi or something. I don't know. Okay. So, removed. Verify true from masking. Let me see what we removed. Did we remove contracts? Yes, it's empty directories indeed. Okay, but maybe the directories, if they're empty, you can just read of them. Now, did we update the script? Let's check scripts. You see, this is a transaction. This is a transaction. Oh, you can see there's a changes here. Deploy. Okay, so something changed here. Is there a way for me to see what changed? Is it how I do it here? No. Ah, here. Oh, here we go. Verify tuple on masking is removed. Settled facet is added. Perfect. This is Bash script. I deploy everything with Bash scripts. I like Bash. Private poker vars. Okay, so what do we do here? Here something? Oh, here we go. Some vars. Ah, okay. Settler was added. Let's see this. Oh, what happened here? Ah, okay. Right, and there is some changes here as well. Okay. Anyway, I trust that the changes are correct because I can see they look correct. So this is just scripts. Right, poker chain config. So that actually is important. So when I deploy, I will deploy in a moment, and I will use this as well. Then there is new addresses under which those contracts are deployed, and I need to put those addresses in the config of my application. So I need to go here. I need to put everything in this JSON config. But why would I do it by hand if I can have a script that does it? So that's how it works now. Could be done better, perhaps. I don't know. Everyone is using this Node.js for scripting, for those kind of scripts. I don't have Node.js here. In Vita, yes, but this is contracts and this is Rust. You know, this is all Rust, and I just use Bash for this. And I have to use Bash because you see, to deploy something in Rust Stylus, you have to use command line tool, cargo stylus. Actually, it's a cargo stylus. It's cargo module for cargo. So yeah, you can actually build cargo stylus separately, but it's a cargo module, so you need to use, where is it? This is the core private poker vars. This is the core of my magical scripts for Bash. So if you look at the other scripts, like for example, I don't know, deploy something. Oh, this one is actually big. Deploy contract. You see, it just calls deploy. So what I'm doing, I'm kind of including this, including private poker vars, and I say deploy. You know, this is the final. So everything is actually, I have all these functions here, and they do magic. Okay, anyway, those changes look correct. Cargo, blah blah blah. Okay, I presume it works. I'm not going to waste time checking this. Some changes here. Why? What happened here? What did we change? Stylus SDK dependency. Why did we remove this? That is curious. I don't think we should be removing Stylus as, it's here. Because test, there is no test. But why? I don't want to remove it. Codex, why did you remove it? Who asked you to? Okay, before I might revert this change. I don't like this. Bring this back. Although it doesn't matter really, because I probably don't have a test here, that's why. So this is kind of interesting. How do you test those smart contracts? So this is a smart contract, right? There's a thing called entry point. So every smart contract has the entry point. So in this case, private poker settler, this is entry point. It's an empty struct. Data is stored in main lobby that's shared in the slot storage. But yeah, and then you have tests, and these are regular cargo tests. Just do cargo tests. I can show you. Just like that, and bang, it will just test it. It will build it first, but yeah, it will test it. So these tests actually are not using the VM even. Okay, I don't know what's that. What Codex did here. Settler, private poker diamond. Let's see diamond. Does diamond have more interesting tests? The selectors. Yeah, it's just basic stuff. There is no, because you can test smart contracts as well, but I can see that there is no actual test of smart contracts that I would be interested in. You can see 0 tests. Maybe that's the task for future me, to either write tests or ask Codex to do it. Knowing me, I'm gonna just ask Codex, because why should I be typing so much? Okay, let's deploy this. Okay, so I actually have a README here to do that, because here we go. I don't need to be remembering everything. My mind doesn't remember anything. So let me just kill this. That's Nitro dev node. So I just run fresh Nitro dev node. That's a fresh Nitro dev node. Hooray! Now we have new smart contract. So I think the very first thing we need to do, check contracts. Okay, check all contracts, please. Just to rebuild everything, because we have to rebuild all smart contracts because we changed this shared data structures. So we have to rebuild them. Now there is this problem, because when smart contracts are evolving, how do you upgrade them? How do you, oh no, that's not gonna run. This ain't gonna run. 35. Oh no. You see, this is sad. I need to figure out. 35 is too much. It has to fit into 24. Why are you so big? Oh, what made you so big? And cell. Oh my goodness. Too much stuff in here. I don't know. Yeah. I think we need to put this thing into separate smart contract as it was before, into verify something. Yeah. We just create a separate contract because I think maybe those data structures take space. I don't know. It's big and optimizations are enabled, are they? They are per workspace, so should be yeah. Maybe I'm not building dev, am I? I don't think so. So it is. Okay, we need to tell Codex some small changes here. Okay. So this is what I'm gonna do now. I'm gonna tell Codex that this doesn't work. Hey, this won't fly. And you might think, why am I talking like this to AI? Because I like that. 35.6 kilo for settler won't deploy. We need to separate verify signature, I suppose. Is that into utilities smart contract and just call it from can be called verify just signature the smart contract and private poker verify signature. That's the name of that's the actual name, you see, private poker settler. Okay, yeah, that's fine. Settle hand. I'm just guessing that this is like, let me just check. I'm just gonna do this. Is it okay? Can I comment this? Just want to see if that will, tests are not important. How much will that shrink the binary? I mean, should be fine. Okay, let's see. Check contract. How big is that now? Failed. Lol. Why did you fail? Doesn't show, of course, because everything goes to null. I need to go to contracts, settler, cargo, stylus, track. Oh, here we go. Make 2G. Where is make 2G used? Huh? Who's using this one? Ah, tests. Okay, good enough. No, more. Ah, here it is. Oh, aggregate public key. Mapper, but this is just error check? Why are we doing error check like this? What for? You see, I need to fix code after codex all the time. It's like, could not, okay, fair enough, okay, but now it compiles. And, 20, okay. So, as I said, it will fit when we remove all this from this. Yeah. The code that I take my contract. Just to make the okay, will it work? Does Codex know what to do? Let's see. Oh, I can see the chat. Okay. Okay, so yeah, so I can't move the chat window anywhere. Or maybe I can. Maybe if I move, actually, maybe if I do this. Oh, well, the chat window now. Oh, the chat window is here. Cool. I can see. But I just put it here. I don't need this to be. Well, I don't know. It's kind of funny. No, it's I don't know. It's annoying me. Yeah. So you don't know what's annoying me because you don't see it. It's excluded from the recording. On the app that is actually used for recording, it's called Op Studio. And yeah, I tick the box to exclude it from the capture, so it doesn't show. But it is all the way on my Windows here. It's kind of annoying me. But I think that's the way for me to have chat as well here, in case I wanted to have chat. And it kind of, this chat disappears whenever I click on something. Huh, weird. Live chat. Oh, I see. And can I make it on top, always on top or something? I don't know. What? Always on top. Okay, that doesn't work. Because now everything is on top. Oh, this is Op Studio. So what is it doing here? Settler, verify signature. Okay, is it separate contract? Okay, what did we do at the verifier? Verifies. You see how this works now. So this I'll show you. Verify signature. Oh, and here you have this small contract, private poker verify signature. This is the simple call here, verify signature inner. Here we go. We have the Miller loop here, and then we call this function. So this verify signature needs to be exposed in public interface. For that, we have lobby here, and we have those solidity things, and it's somewhere here, maybe somewhere here. Oh, here we go. It's here, right? So we have this, and to use this, we just do like that. Private poker verify signature call. So that creates a call structure, This is the data for it. So those are the parameters you would pass to this thing. Actually, those parameters here in this interface. And then this is you see, this is the verify signature call. So this is like a data structure. So parameters together with the selector are packed into this structure. And then this call bool that Codex has synthesized, which is here. So you can see that to call, you actually get this. See this, see that's what happens here. So this verify signature, right? So that is address. So it's like calling a method on the object, right? So it's like a pointer. So there's an address, and then there is like the verify ABI encode. So this is this data structure which contains this selector. So this ABI encode will make it bytes. We go here. You see the call data is no bytes, it's ABI encoded. So we take this call data and we tell VM. So we take from our context, from our private poker settler, we take the VM and we say, okay, VM, call me on this destination address this function. Okay, and that's the output. And then there is this thing ABI decode to get the boolean from this thing. You know, and then you return the boolean. So it's kind of low level for smart contracts call. You'd like something like just call function, and that's how you do it in Rust Stylus. Okay. And to emit events, you do it like this. Just publish event like this. Okay. So what did we do? Are we good now? What happens if I build all contracts? Let's see how big are they. I presume I have to rebuild everything because, of course, the structure has changed. Specifically, private poker facet addresses and verify signature landed here, even though it is not a facet, but I don't know, it's okay. I mean, I'm not going to be that pedantic. All right, so let's look. Settler 21 kilobytes, verify signature 21 kilobytes. It was 35 and now it's 43. Right? The boilerplate. Okay. Cool. And did we change the scripts as well? Can I see the diff review? I want to see this file. No? I have to find it in here. How do I do that? No, I hate it. I have to scroll it. Oh, here we go. No. I don't like this interface. Okay, anyway, what did it say it did? So we did the split. Done, split. Okay. We have those tests in there. So the tests are here. We can. No, this is not what I wanted. I wanted to run tests. They pass. What they do, they call signature verification. Here we go. Good enough. Okay, let's see. Let's see. But we changed Vita as well. Why? What did we change in Vita? We added this. But we don't need verify signature on the Vita side. What did it do? Okay, verify signature, contract address, gone, cool. How about the shell script? Ah, yeah, okay. You see? I mean, me and Codex, we know each other. We understand each other as if we knew each other for 1,000 years. Okay, do I want to bother with this to check? Or do I want to just QA it first? You may wonder, how is it even, like, just out of curiosity, you may wonder, how is it possible that this code is so organized? This is React, okay? This is extremely complex React. This is, the complexity of this code base is just beyond imagination. How on earth AI didn't F it up, you know? Didn't make it like one big mess. Well, it's designed, okay? Everything here is designed, so yeah, I didn't just go ahead and do random stuff. Everything is well designed. The protocol, the whole, you have the RTC session pool, so you have a pulling of the peer-to-peer connections. You have client for the blockchain, public client. So if you want to query like wallet balance or something like that, you have all these hooks here. So for example, the big one, use poker table. Okay, so that's the big one. So that is, I actually have to bring it in so I can see a chat, but now I won't see it. That's not cool. So what's the point of this chat if I cannot see it? Well, anyway, I'll check if someone is typing from time to time. Okay, so what do we have here? So that's use poker table. So the way these things work in React, it's like, imagine those plugs that you put one plug into another and then another plug, like lots of plugs, you know? You keep plugging them one into another, kind of. So yeah, it's actually hard to explain because there is a state as well stored kind of implicitly with those. So these aren't just like function calls. Where is the beginning of it? Use. So for example, this is use poker table, and what does use? Let's go to the table and just see how those plugs are, like you know, like a spider, like a web of those plugs. So let's look at the thing. Not sure it's gonna be like not here. I think it's gonna be component. I didn't ask for it. I think it's gonna be in components actually. Whoa, question where? Table screen, dialogues. Yeah, there was a time when I had Codex to refactor it because it was one big file and I didn't like it. So now we have lots of big files. Okay, table client on the client side of the well, there is no server side. It used to be Next.js app, but now it's no longer Next.js app. Everything is front-end. There is no backend. And you can see all this. So you will find here something like use well, use state as well, but use webcam, use table, use poker table. Okay, so you do use poker table, and then that goes in. So you can see that one view uses lots of them, and then use poker table uses more other things. Or use final verification, right? So use poker. So poker table is plugged into use poker table, which is plugged into use final verification. There's also definitely all those others like use RTC session pool. Is it not using it? I'm pretty sure it's using it here. No? Yeah, I don't remember what is where. Use. Yeah, I'm lost here. Use poker table, stable. What does this one do? Use account session, private poker lobby. Oh, here we go. Yeah. And then this one, use private poker lobby, is our hook for the blockchain. You see all those ABI of those smart contracts. So this gives you all those stuff. And then for watching some events, you have this, listen for new tables, listen for new lobbies. So that's it uses the VM, VIEM framework. If you look at the context, BLS context, no, providers. Oh, providers. So how is this? How is this structured? There is an app. Oh, here's the app. This is an app, and then app routes to those things. And wait a second. First, there is providers. Oh, here we go. So that's the root. Then there is providers. Providers are those providers. Web3 provider, so that's a wallet, Web3 wallet. Account session provider, I don't remember what, I know what it is. This is the operator. And then you have BLS provider for BLS cryptography. And then you have children, which is app. And app is this. And then we route into those. And those are here. Oh, this is the website. And then you have, and they use components. So you can, for example, see tables. We have a page, table client. Oh, so the table page is essentially table client here with some extras. And then the layout of this is here. It's just this in this case. So it's not very complicated in this case. So yeah, for splash screen, for maybe main page, the splash. Okay, it's just splash. So the splash page will have all the. It's a splash. Cool. And splash is from splash components. Oh, here we go. And that is our splash screen. How do we navigate from splash screen to the next screen? Oh, Jesus. I don't know. I think there is some redirection somewhere. I sign in. Oh, here we go. Timer. There is a timer here. So the fade out is in 2000 millis and 2500 we go into sign in. Then we have sign in here somewhere. Oh, here we go, and that's our page. Account sign in. So it's pretty cool. React is really, really pretty cool. It's just everything everywhere. But it's cool. I like it. Way more than Angular. Angular is terrible. I'm glad that no one is using Angular anymore, because I really didn't like it. It was horrible. Yeah. Okay, so what are we saying? I wanted to see if final verification is using this new blockchain. Doesn't look like it. Okay, let's ask, hey, are we using this new feature? What are we using? Settler. See, I asked Codex to create it some minutes ago and I completely forgot what was it named. I don't remember what I was thinking half an hour ago. Settle hand. Oh. Codex will know what I say instead of the console output. So yeah, but in the meantime, so and we did that. Okay. Now next step is we can keep USDT, USDC stuff, I think. What can we do here? I don't want to do this. I want to just do this. Private poker. Deploy, just like that. New smart. Oh no. No. I have to because this is a new node. Okay, let me just start from the beginning. In development, it's so easy. I just start brand new Arbitrum chain on my local machine. That's my Nitro node running. And now everything is fresh. So I can just go ahead and like, okay. Just to be sure, because I have a feeling that maybe there was a change in some smart contracts that we didn't build or something. And with smart contracts, the thing is that better safe than sorry. So if you don't want to be chasing for an hour or two some problem just because one of the smart contracts wasn't rebuilt. Yeah. So smart contracts is just code, and in my case, they're just Rust. So easy peasy. Now I'm gonna put this into environment. This defines. This actually will put into environment those addresses. Then I do this. Bang, and that will deploy all the smart contracts. Let's see what Codex was saying. What is mentioning about operator? I'm adding small ABI just for settler calls. Blah blah blah. Okay. Good enough. We need to still fix the signing because, but okay, let's just see if it works. Let's go a little step at the moment. Okay. One little step at a time. Not too much. Let's not go crazy. Okay, so next step here is to do this. We need a lobby. Without a lobby, there won't be any games. No fun. I have already said that I would invent something new, and I already have an idea of, I think, at least 2 new inventions. So they also would use BLS cryptography and peer-to-peer technology, but I have some new applications for this technology. You know, I have some new things in my head. Okay, add lobby. What did we do? Accounts, fund accounts, test accounts. We can fund test accounts because maybe Codex wants to use them. Test accounts are those from Anvil, you know. Anvil and Hard Hat, I think they both use the same. Okay, that's okay. Now, what does Codex say? Codex say it finished, done. The Vita app now calls settle hand. Okay, where is the? I want to review this change. Can I review this change? Okay, where is it calling it? Parsabi, okay. Args. And just this. Some checks. Fair enough. What is this? Final verification. Was okay, just moved things around and created this callback to do settlement contract args right from operator. Okay. So this is the magic. This will use special entity, the operator, and that's just to make this whole Web3 app look and feel of a Web2 app, you know. You just log in, that's it. You don't have to worry about wallets. So it has some, well, mostly it's advantages. There is no disadvantages to that really. It's really convenient. Okay. Gas overrides. Why do we care about doing this? I won't be bothered. It sounds like we're caching some gas amounts or something. This is the call. It's called mutate async. Yeah, so we're changing the data. We're sending to this address. This is diamond, settle hand, and that will go and to this diamond here. And there is this fallback. We go to this fallback. The selector will be settle hands. Then we go here to this Facet from selector, and that will do this, and that will find settle hand call. We'll say settler. We'll go back here. We'll select the settler address. We go back here and it will call contract on settler, and the settler is here. Now we're gonna do settle hand. Let's ask Codex if we did this. I don't think he forgot. No, there's only this. Ha. The first hand starts, so when all players have announced their public keys. Or hand starts. Ha. Ta-da! We need this. Without this, the verification won't work. Okay, so it's ridiculous how my queries are like this, you know. Now, but I like it. I mean, Codex is there to do the work, not me, right? I'm just the boss here. Okay, so it will go first. It will go here. Before the first hand starts, we need to have this aggregate public key from all players. Now this worries me a little bit. Who is gonna send that? Which player? I don't feel like a player should be sending aggregate public key. This should be aggregated automatically from the table, I think. I need to check that. So where is the announce? Yeah, this one. And this I think this is some. Yeah, we need to remove this, I think. I have a feeling. We don't need, yes, I need to ask. Okay, we need to remove here from the hand, we need to remove this, this needs to be removed. Yeah, okay. Okay, what did we do? Oh, okay, so we did some changes. So you may think, okay, we're doing some shuffling of the code. We're changing here, we're changing there. How this is not gonna work? Well, I don't know. Maybe it won't. We'll fix it. I have Codex, and I will use it to fix it. Why do I need start hand? At this, but start hand is a different contract. Is it hand contract? Yeah. Yeah, I think I'm not sure because this settler. Why do we need settler? Maybe this is to be replaced. Yeah, I have a feeling that the poker hand contract is what we need to just have. Yeah, I think so. Oh my god, I'll have to redeploy everything again. How's the chat doing? Oh, I'm coding private poker, you know? I'm coding this thing. I'm gonna show you what I'm coding. Second. I'm gonna show you what I'm coding. I am coding this. Oh, this thing. I'm coding this. So sign in, and here we go. And here I am, and I can continue. See, this is what I'm coding. So okay. No, it's all Rust. There's no backend. What backend? There is no backend. It's blockchain app. There is no backend. This is backend. This private poker contracts. No, smart contracts. Smart contracts are the backend. You know. Okay, so that's the game, and that's what I'm working on, trying to make it better. Where did we finish? I have a feeling that I'll continue maybe tomorrow because I'm sleepy. It's already 1 at night. Although I'm feeling I like my project. The amount of challenge here is just beyond expectations. It's a lot of fun. Okay, so final settlement test. Why is it not working? Use poker table final verification. Where is this guy? Hello. Ah, here. No, come back. Announce public key. Okay. Let's see what it says. Now call set table aggregate key via diamond before gameplay actions proceed. Okay. Let's see, because final settlement. Okay. So what do we have here? Hand setup. Table aggregate public key. Oh. And where does it go? I don't see a call to a smart contract. Settlement contract args. Oh, I need to tell Codex to bring the whole gameplay here. Again. Yeah. I think so. I think I would like to see the whole gameplay. Yeah, the whole thing. Create table. Join table. Yeah, I want full scenario. Yeah. Yeah. We're bringing. I wonder how much I have left tokens. 53%. Oh no. Oh my god. I'm so poor. I can't afford more. What am I gonna do? I'm gonna start GoFundMe. GoFund my Codex. There is no backup. Yeah. What is this warning about? This is warning. I don't know why it's warning. What is it warning me? I don't know. It's warning me of something. Okie dokie. Do we have all the stages now? Hand setup. Where is the table? Just wait for Codex. We'll finish in the moment. Yeah, I need new tea. So yeah, so that's my coding for my app. Coding of my app. Yeah, that's what it is. .5 megabits per second. That's okay, I guess. I don't know. How's the stream looking like? Wonder who's got the daytime now. US, no? In US you have daytime. I don't see this stream here. Should be showing. So what are we doing here? Into full local lifecycle test. Yes, yeah, makes sense. Full gameplay. I found the existing test in single local hand object plus final signatures. Oh, okay. That's exactly why I want this full flow. I want to see the full flow in a test case because of things like that. And yeah. So Codex is doing the coding for me. So what we're building here is a peer-to-peer poker, and that is this final stage here to just make this final settlement. But the technology is interesting because what you get is a hybrid of blockchain and peer-to-peer. So you have a web app which is just front end. There is no backend, just front end. Everything is JavaScript, and yeah, and then JavaScript is using like React, and it submits on blockchain transactions. So blockchain becomes like a backend. So what's the story? We have some changes here. Some changes to use final verification. Hand signatures. Our Codex is being creative. That's fine. A cool thing is, I think the reason why it goes so pretty well with the front end is because it all kind of starts from smart contracts. There's like a Pokemon gameplay is peer-to-peer, but then the games happen like on blockchain you have like lobbies and games. You start the table, create table, you start a hand. That happens on blockchain. And then the gameplay of the hand is peer-to-peer. And then when someone wins the hand, that's settled on chain. So the flow is interesting. And it's like a roll-up, but in a different way, you know? It's like, yeah, it's essentially kind of, it's like kind of like a roll-up, kind of, because like the gameplay is off the chain, peer-to-peer, and when it finishes, it settles, right? And you have like some digest of what happened, and the digest is actually of this. Maybe I show later when this is finished here. So I made that the chain, the hand itself is kind of like a little chain. So the start hand, it's a chain with nothing on it. You make your first action, you add your action to this chain, and then it just grows, and it's passed over. This whole mini chain is passed over across players using peer-to-peer network. So it's like a blockchain, but without blocks, because you don't need them. It's more, the reason that it actually works is because poker has rules, and if you pass a chain that's wrong, you'll be nominated cheater. So the chain has to be correct, like this little chain of events have to be, you know, because next player will apply the delta, so it will take from this chain all the actions that they haven't seen, right? If there is 2 players, it's only one action of previous player, but if there is 3 players, then it will take 2 players' actions, and they all signed BLS. So yeah. So I'm making action. I'm deciding I'm gonna bet. So I'm gonna add this bet onto this chain, and I'm gonna sign it, and I'm gonna pass to you the new chain. I can't really modify the chain, because if I do, the next player knows what was the chain before and only knows the delta is missing, and then you cannot apply the actions, right? You can't apply the actions. They have to be signed by other players as well. So anyway, let's see what will happen. It keeps taking time. It keeps taking time. Oh my god. Sonia is producing herself live. I just thought it would be cool to show myself to the world sometimes. I don't recently record any videos, so what are we doing? Are we having oh, we have new tests. Helpers. What is this? Play finish peer-to-peer hand. Well, we don't need to use peer-to-peer in this test, do we? I can see that Codex got a little bit more advanced here. No? Poker action. Not sure. Or is it hard-coded? Get columns required. Shuffle traced. Deterministic range. RNG, deterministic RNG. Oh. That's smart, let's say. Okay. Where is the test? This is the test. Okay. Test chain, my chain, public, okay, client. Play, finish, peer-to-peer, hand. And where is the beginning of the game? Ah, okay. Prepare player, transfer Facet, subscribe, approve, balance. Oh, this is interesting. What are we doing here? Creating a player, giving them chips from Facet. What is this? Where's the part when we join the table? Prepare player. Ah. Okay. What is this? Okay. Let's join. Set aggregate. Okay, so join and then this. And then this. And does it work? And so, is this? It was deployed. Okay. Test live. How does that work? Does it work? Do we have any interaction with the chain? It passed. Look at that. The test passes. But I don't remember updating the... I guess Codex has done it. Let's check. Well, I guess these contract addresses just don't change. Because when you start new node, when you deploy, you're gonna get the same address, I think. 1 to 4. I think it's the same address. That's why it works. I don't know, where is the other one? Oh, here, 80. This one. Okay. Oh. So, they deployed. Okay. What can we do now? Let's try it. See what happens. Are we running? No, we're not running. Okay, okay. npm run dev. So I actually exported into environment a variable that says to run on this localhost dev node. Because by default it would use Sepolia. I probably don't have gas token on this ABC. Yeah, I need to send token to this account, because I just deployed everything fresh, so I have to do I'm just gonna use cast send .2 ether, and I'm gonna as well do the same thing for this other guy here. Okay. That's one thing, and also scripts font. What is this? USDC. Okay, I can just put here paste, and this guy as well. Okay, should be fine now. Let's try again. ABC. So that's a subscription thing. True. I don't remember what is this. Signing a lot of things. Nitro dev. No. I don't know why it failed. What does it say? Okay, it's some I think the failure like this happens only on this dev chain. Maybe I'm clicking too fast. I don't know. Oh, the calculation of the gas didn't work out or something. Oh, now it worked. I don't know if there's some lobbies. Create new table. Okay. Boom. Join. So this is our blockchain. Bind. Okay, I need to add the retry here, automated, because now I need to poke again. Oh, wow, now they work. If it automatically retried. Oh, okay, Codex broke it. Ha ha ha. Didn't enter the gameplay. Is there any error or something in the console? Accept, connected, join, offer poke. Okay, nothing special. Scatter server RTC proof. That's RTC. That's this is the peer-to-peer. Okay, there is peer-to-peer stuff going on. I wonder what will happen if I try to connect again. Like, let's say I just go ahead and return. Open table. Or this? No, it's definitely Codex broke something. Yeah. Okay, and I don't have right now energy to continue because it's already 1:30. So I will need to ask Codex to fix it or check what it broke, whichever gets me to the outcome I want. Okay, let's try this. I'm trying now the app, and seem to be no bind action. Something with the state change. Hand state change. So what did it change here? How did it break this poker table? Final segment. Why did it change final verification? Okay, final verification is not that important now. Table assigning key, table keys. We did something here. What do we do? Next game, change some data. There is some weird stuff in UI. What is this? Why do we need this? That begs a question, because I didn't remember authorizing this. Why would that be excluded? Codex is hallucinating stuff. I need to fix this. But it's like it's going there, but going there, like eventually going somewhere towards the right direction. So it's good I'm here to make sure that things are in the right place. Any comments? No? Okay. But seriously, once this prompt finishes, I need to go to sleep. That is, usage is already 46%, so maybe time to sleep. High, maybe I shouldn't be using high effort. Extra high will be extra high. Okay, maybe. I don't know. Public key on chain. Submit promise. Submit. Aggregate. I have a feeling that this promise is supposed to continue with blinds, and it didn't. What is it saying? Enter key. this. It's hard to figure this out. What was here? I want to expand this. Huh. So instead of doing set aggregate public chain and returning, now we're creating a promise. But this is a promise anyway. So what is the point of doing this? To stick it in this game. And then return it like this. Await on it. And then once we finish awaiting, set to null. And then it will just check for it. Okay. So let's see if that would work. Okay, I don't like this. I feel like there should be an explicit state. Well, it didn't work as far as I can see. Invalid signature. That's another story. Invalid signature. What signature is invalid? I'll tell you this. I can't, I'm sleeping. My eyes are closing. Need to tell Codex goodbye. Need to kill Nitro. Sorry, Nitro. Need to go to sleep, you know. Alright, so I'm gonna finish this. I just did this broadcast because I was curious how this will turn out. If the quality will be bad or good or whatever. This is in higher resolution than last time, so maybe text is more visible. I will continue development of my poker app surely. Yeah, and yeah, see you next time. And now